Hi everyone, welcome back. Today we're going to talk about how to calibrate the color sensor. So the color sensors with 4 LEDs there. We're going to use the same program, car test sensor 2021-0107. And yeah, maybe I just run the program, download the program and then run it again. Sometimes if this screen stuck, you may need to refresh it, like close it and then start it again. And take a while for the OLED to turn on. And yeah, so let's take a look if it's red color. If it's red color, you see this is, let's see, these are the value we get. And remember to take the values like maximum and minimum, so we can have a range. So now it is red color. And now we go to the green color. You see there's some different. So that's how we tell is it green or red. And for example, in green paper, you see there's 4 value here. That's 4 value mean clear, red, blue, and green filter. So the green paper is not actually green. It has some other data in there. So yeah, so this is the value we get. Let's take a look of the code. Why we need to do something like this. This is the color input. So first we set the clear filter. So S2 and S3 is to set the filter. After we set the filter, we have the delay, and then pulse in is like sometimes like really slow, especially if it's a dark color. So that's why that 4 LED is to increase the pulse width, reduce the pulse width, so it will get it like faster. So this is the color value C, so it's clear filter data. And then we set the S2 and S3 to something to 00 is for red, and then do the same things. Blue, let's do the same things, and then green, do the same thing. And then after that, we print it up. So these are the 4 data. And then after that, these you guys have to do it yourself. For example, what's the meaning? How you can determine if it's green color? You have to set the range. If you get the data range is within certain within this range, then it is green. If not, then it is red. So that's it. So that's how to do the color check. And as you see, I put some delay in the color input is to be sure you get the correct data. Because when the robot keep running, last year people say if it runs because the robot go up and down or the voltage is not stable, it's not always 5 volt, we may get wrong range of data, and then the car may turn or recognize it's like red, but it's not red or something. So that's why when you do the project, remember use the far left and far right sensor. As soon as that 2 sensor see the black line, then stop the car and use the color sensor to check is it green paper or red paper. So it's the best method, because think about that. If the car is running and then, for example, you have a delay somewhere, and then if it's delay, it means that whatever it's doing, it will keep doing. So if the car keep going this way, it may go away instead of following the black line, because for the delay, it's not taking any data from the sensor value, so you don't know what happened. So if there's something to remind you guys, if you need to use a delay, remember to use the delay when the car is stopped. Other than that, do not use the delay. And when the car stop, detect the color sensor. You can also detect check the ultrasonic sensor, or check the power, the coil. That's why in the code I wrote something like this here. So for this data, this there's one called color check too. But anyway, there's a color check. So for this subroutine data, as soon as it takes some time to do it, it's good that when the car is stopped, then you do it. Do not put it in the back loop. And for sure, you have to do some if statement here and say if either the sensor see the black line or see the rising edge of the black line. I can talk about the rising edge or falling edge later, but it just say when it see the black line, it means that it is in the intersection. Then you should stop the car and then do the checking here and there. And also in here you may need to display the OLED coordinate later, but it is in your project. And then yeah, everything should do it. I mean, any things that need times to do it should do it when the car is stopped at the intersection. And why it's good to stay in the intersection. For example, the car is moving forward and see something, and then it detects it check all the ultrasonic and then the color sensor, right? After that, if we need to keep going, so it will keep going. If the robot have to turn, then it will turn up to this point and it will stop, and then it will go. So turn left and right, you guys have to do it. And something to remind you guys is that before you guys have the code of going forward, right? And if the robot does not see the black line, or just one of them see a black line, this sensor, this event should override the straight line function. So it should, for example, if the robot should be on the straight line, on the black line, then you can call the forward straight line function, or like initialize the function and then start. Or else the encoder and the black light sensor will fight each other, and you don't know, the robot doesn't know if it go forward or turn or something. So but you will know that later when you start doing the black line follow, and yeah, you have experience of how to do it. So more information about this robot. Say, okay, these two sensor, yeah, it can detect the black line, but remember to see if the robot go up and down, it actually detects something else. For example, here, or this green line. Okay, yeah. So you may need to tune the trim later so that the black line sensors actually can detect the black line even with the robot going up and down, up and down. So that's something you have to do. And for the OLED, it's always good to use for displaying some debugging program, debugging statement. But remember, same as before, because OLED take a long time to send data back and forward. So it's good to display it, print out when the car is stopped. So yeah, so for your project, I can see the most difficult part is that student get this working, and then student get this working. So separately it works, but as soon as they put them together, there's something happen. And the best way to eliminate that is to stop the car, do this, do that, do that, do that, and then move the car again, because you're supposed to know how to follow the black line and go forward. And then as soon as the robot stop, so that's a routine will be done. So as if you get the go forward program working and then it's done, so you forget about that and you go to the next part, and do not mix the program together, because I mean, do the functions like one by one is the best way, because for example, you after you finish the right turn and then you stop, everything's work fine, you're not like away from the intersection or the wrong direction, then you turn 90 degree, and that 90 degrees should give you the 90 degree exact, and then after that do something else. So you can chop the big program into separate part. And how to chop it is like you use a if statement, if this and that. It's like a state machine if you have learned it, but if not, that's okay. But remember to get a pen and paper, write the if statements. I mean, write the say if it see the green paper, what it's supposed to do. If you see the green paper is supposed what it's supposed to do. If you see the black line like this, like the intersection, what it's supposed to do. So you draw a diagrams like the if else statement, then it's easier for you to debug. And yeah, and also I will put this robot in the lab. So if you guys have any questions, you can also take a look of the wire. So yeah, so that's something like this. So thanks for watching.